Hello and welcome back, boys and girls. So today I'm going to solve and discuss with you a paper from a practical side. Okay, so you see this is your paper 3 advanced practical skills 1, and this is 9701/33. Many of you are registered for 3.3 or some of you may be registered for 3.4, but inshallah I will try to discuss both the questions. And remember, there is a what we can say very slightly changes, but the overall procedure I might advise you to focus on that. Okay, so only focus on the procedure which is being discussed in this question. You can apply this to every question which you are solving. Like for example, today we are going to solve the first question of the same paper, and that is related to, let me see, okay, so this is titration. This is what? A titration method. So all of the necessary steps which we are going to discuss here in this question remains the same, 100% same. So my advice to focus on the pattern which I am going to discuss with you. Okay, rest could be or there should be some slight changes according to the demand of the question, but the main situations 100% remains the same. So without wasting any further time, I'm going to solve and discuss with you with this question. And here it says that quantitative analysis. Okay, so in quantitative we are going to perform a practical procedure and try to get a relevant data, and from that relevant data we are going to solve some mathematical questions and going to predict something, maybe about the formula of the compound, maybe about the what we can say purity of the compound or impurity. So any of these situations could be asked in these titration questions. So again, you have to follow the instruction, you have to read all these instructions because all of them are going to help you a lot. So read the instructions carefully. In your practical exam, first tip is that read the instructions carefully and then perform the practical. Okay, but while you are performing your practical, you have to focus that you may perform once or twice. When you perform once, note it down, all those readings inside your paper. No need to write down or note down any reading inside the paper. Note it down roughly with your pencil on your paper. Okay, to the side, like I'm going to perform any titration and you have to solve and you have to note down in a rough way at the side of your exam paper. Then perform the second reading. When you perform the second titration, this will actually help you out to figure it out that the performance of the first titration and the second titration was correct. When your results are close enough to each other, then yes, it means the procedure you followed is okay, there is no problem. But if the first reading you got and the second reading you got has a huge gap, then it means you have done some mistake. So at this stage, no need to go and proceed for the third titration. Then please follow the theoretical method which I'm going to explain in this video. Okay, so if you want to perform the third titration, that will cost you more time. And that will disturb your whole paper, whole exam. So please, no need to go for the third. 2 are enough to give you the idea that your titration, your performance is okay. Is that clear? So no need to perform the third one. For the third one, I'm giving you a hack. So focus on that and try to do accordingly. When you perform, so these instructions were there. If I read for you, that he says that the redox reaction is taking place and we are about to choose which of these 1, 2 or 3 equation is the best implemented to the procedure which we are following and performing here. So now focus on the instructions of this question. In this question, he says that you will carry out titration determine which of equation 1, 2, 3 are the best. So this is the procedure. He says FA1. So now focus and remember that what type of the chemical you are using, what are those and what they are labeled. Clear? So FA1, he says that this is the potassium manganate solution and its concentration is known to you. Second, FA2 is another solution which he freshly prepared. You are not going to prepare. He says that this is already prepared. How? By taking 1 dm cube of the solution and adding 3.30 gram of the hydroxylamine hydrochloride. This is a complex formula. No need to again confuse with this. You have a ready-made Fa2 solution, but this information could be involved in further calculation. So right now there is no what we can say discussion on that, so I am proceeding. Second, he says that Fa3 is another solution and this is dilute sulfuric acid. Now first method he clearly mentioning you have to follow exactly what he is trying to do, then perform your practical procedure. After doing all these procedural requirements, let me explain in a very short way what you are going to do. Okay, what you are going to do and how you are going to follow these instructions. Pay attention carefully. You may watch this part again and again to better understand what is the procedure and how you are going to follow this. So first he says that fill out the burette. You have the burette, so like this, you have this burette that is fitted with a burette stand, okay, or maybe that is just laying on the table alongside the burette stand. So your first instruction, this is not written here, what you are going to do, check, first of all check that the tap is properly working. You can easily turn it on or off, just rotate it to help yourself that it is enough and there is no stuck or there is no any problem of rotating this thingy. Now attach it to the burette stand that is fitted with the burette clamp. Okay, here burette stand and burette clamp, just attach this out carefully. After that, again check the tap should be closed. This tap should be closed. Okay, and now what you are going to do, place a glass funnel like this and then start to add Fa1. Carefully, listen carefully. First of all, close the tap, then place the glass funnel, try to add the Fa1 slowly. When you are adding, try to, like you see there is a proper gap. This is to displace the air. So keep this glass funnel slightly up so that the solution could easily go in. If you just place it over this position, this will block the air displacement. What happened? The liquid will not go fastly and it will stuck here and it may splash out and wastage of the what we can say material happens, and if examiner notice, that may go in not in your favor. Okay, so please try to add carefully, slowly, and try to pull this glass funnel slightly up. After that, try to make it till 0, or my advice is to add little above the 0. This is 0 and add your solution little above the 0. Now this time why? Try to take the conical flask, empty conical flask, without having anything in it. Okay, and now what to do? Tap on so that you can easily see that something is coming out, and try to make the reading exactly at 0, or at least follow that it may comes out down the 0. Okay, why we are doing this? So in this way you are actually trying to have a control on your tap, when to make it open, close, or slow it down. So while you are filtering, or sorry, adding from the burette, you are actually trying to get the control on your tap. Okay, at least make it 0 or below the 0, and that close the tap again. Close the tap again. Now this time discard this thingy. Discard this thingy. Actually this help you to, if something is stuck here in the burette, it may wash away, plus it will give you help to control the tap. Okay, how to close, how to slow it down, or how to open. Is that clear? After that you have to discarding and then wash the flask again and then place it again. Wash it and then place it again. Is that clear? Now second, he says that after this instruction is completely done, you have to go for the pipette. He says that take the pipette, fill it up with the Fa2 and add it into the conical flask. After washing the flask, take the flask. Now this time add from the burette the Fa2 here. Fa2 in this flask by using the pipette with pipette filler. Take care of the, what we can say, reading how to take the pipette filler. I might advise you to please have a practice of taking the liquid, taking the volume, measuring the volume from by the use of the what we can say pipette in your practical sessions at your school. Okay, if you are a private candidate, try to at least have the practice of these things. Okay, then after that, second thing is the third one, sorry, he says that take the 25 centimeter cube measuring cylinder. Its capacity is more, so no need to worry about that. Okay, this is the measuring cylinder having the total capacity of what, 25, but add from this how much? This is Fa3, which he clearly mentioned it was sulfuric acid. So add the Fa3, how much? Till 10 centimeter cube, and then pour it into the flask. Pour it into the flask. After that you have to place this flask under the burette, sorry, under the what we can say as burette, under the burette. Clearly everything is done. Then you must have to note down the volume. Either it could be 0 or, as I mentioned, just below the 0. Whatever the reading is, try to note it down. That reading will be considered as your initial burette reading, okay, or the initial volume from the burette. Is that clear? So this is about the practical procedure which you are going to you have to do during your practical session. And then I clearly mentioned, if you are not good enough doing this procedure, what you are going to do. These are the hacks. Try to listen carefully now. Okay, let me erase all these. Now again, as I told you, if you are not going to perform all the procedure which I discussed, okay, what you are going to do, this is your hack. Examiner, just pretend that you are performing in your practical exam. Then what to do? Try to make the table. First of all, try to make the table. That table at least have 3 columns, or at least 2, maximum 3. Okay, rows, not columns, sorry, rows, and 2 columns, one which be more, the other is less. Here you have to write, this is fixed, please, no need to remember any other thing than this. Okay, final burette reading, then write /cm cube, or you can say final burette reading in centimeter cube, or you have to write the final burette reading and then add value here and then put cm cube. So remember what is important here, the wording, the heading, plus the unit, which is most important. You must have to add the unit along with this part or along with the reading you are doing here. Then initial burette reading, initial, and then please try to follow the same way, same pattern which you followed here. Initial burette reading, slash cm cube. And then finally in the third row you have to mention volume used, okay. Then again slash cm cube, because this is in the cm cube, and this reading will appear over here. You have to write afterward here. If you're not writing here, then you have to write here, or you have to write on both places. For example, right now I am taking my answer is the final reading. For example, first of all I'm saying the initial reading was 0.00. Then I'm mentioning that the final reading I got is, let me correct it. So the final reading, let's suppose, is 0.00, the initial one, and the final was 24.10, for example. So these are my rough titrations. So why we follow this pattern? Final is up, the initial is down, so that we can easily subtract. And you see the final answer is again 24.10. Okay, so now this is the answer final, so we can say 24.10 is our rough titration. Note it down properly, and I am proceeding. Next, here he says that carry out as many accurate titrations as you think necessary to obtain consistent result. So the main focus is over here, consistent result. You must know what are consistent results. When you have the same readings, or with a very, or we can say less significant gap, that is considered as the gap of 0.1. When you are obtaining the repeated reading with the difference of 0.1 and to the lower side, then you can say you are, or your results which you are obtaining are consistent. Is that clear? But for this you need a lot of time. So my advice, please not to perform as much or as many experiments you are advised. Just try to do 2 results, 2 titrations, to know that your experiment is going on a right side. But if, as I clearly mentioned, the readings you are obtained has the huge gap, a more significant gap in those readings, then consider that you are doing any or something terribly wrong. So then in that scenario, what I told you, please no need to perform more titrations, save your time, and then try to do what I am telling you. Examiner is not checking, okay, your exam paper is going with these results, these presentations. So focus on these presentations only, in case that you are unable to get the accurate, consistent results. Follow the same situation. Here I'm going to write again the final burette reading, slash cm cube, and then you have to write the initial burette reading, slash cm cube. Then you have to mention the volume used. Done. And then here your rough titration, which we already done, so follow the same sequence. Then this should be called as the first titration, this should be called as the second titration, then the third titration, and so on. So that's why examiner is advising, or was advising, to perform as many reading as you can. So for example, as I told you, the rough titration, this is the rough titration, and you are not going to perform or repeat this again, because you already write it. Why I'm writing? So that you have a clear picture what we did earlier. So then I write it 24.10, and the final reading was 24.10. Please try to understand, you are not going to perform this, but if you did this, there is no problem at all. So this was, but you have to mention clearly that was your rough titration. Then you have to say this is your first titration, okay, and then this should be your second titration. So remember, you are going to write only those readings, or as much as you can, but again I'm saying no need to consume more time and performance. Okay, try to go for the presentation like this. So now your first titration must be have the difference of 0.2 to this. If I make the difference of 0.2, the final answer which I am going to obtain will be 23.90 with the difference of 0.2, and your second titration must be with the gap of 0.1. So the answer will be 23.80. Now it's up to you to make these things accordingly so that your final answer should be like this. Okay, so for example, I'm saying my initial reading is 24.10. I didn't fill up the burette again and I'm continuing. Okay, so then how much value should I place over here so that I get this answer? Let me use my calculator so that I can write the accurate readings. So it's 24, I'm going to add actually. Okay, so this will be my final result, 24.10 plus 23.90. So my answer is 48. Okay, so my answer final is 48.00 point. So when you subtract this, you will get this. Again, now this time I'm saying my initial reading is 0. Not 0, so let's say it's 3.55. So in your table must be there is one reading, there should be one reading with this value 0. So making you can rate, or you can what we can say round it off. Okay, so here what I'm going to mention, this should be 5, and let me add again, sorry, with the calculator. So it will be 23.80 plus 3.55. So your final reading should be 27.35. 27.35. So now this table is complete and clearly mentioned that these are the consistent results. These are what? Your consistent results. So now we are proceeding with the calculation of mean titer or mean value. Okay, so now proceeding towards, as I said, towards the mean titer. Okay, how to find the mean titer? As I told you, the values which are consistent. What are the values which are consistent? Remember, the values which have the difference of 0.1 are considered as the consistent results. Only consider or use those, and it was 23.90 plus 23.80 divided by 2. How many readings we have? The reading which are consistent, how many those are, you have to divide and you can get the value, which is 23.85. Is that clear? So this is the way how you can find the mean titer. Then he says calculate the amount in mole of potassium manganate. Okay, remember the concentration of potassium manganate, that was Fa1 was given and was 0.02. okay, and the value or the volume which we titrated using the burette is 23.85. now use the formula N equals to C times V. The concentration in this case is 0.02. the volume in this case we use is 23.85, and then to convert it into decimeter cube divided by 1000. When you do this, you will get the answer. Let me calculate. So 0.02 times 23.85, that is divided by 1000, and the final answer we are getting, that is 4.77 times 10 to the power minus 3 times 10 to the power minus 3. Okay, these are the results. Now please keep this value in your mind as I'm going to raise this. Okay, so 4.77 times 10 to the power minus 3. Next, here he says that use your answer to C1 to calculate, which was our value of manganate ions, and in moles of iron 2 ions in 25 centimeter cube of Fa2. So remember, he gave us the equation. He gave us the equation to make the ratios. What equation? Here he says that whenever the manganate ions are 1 moles, how many moles of iron 2 we require? That is 5. So the ratio of manganate ion which were in Fa1 to the iron 2 ion which were in Fa2 was 5. Was what? 5. So the shortest ratio is 1:5. Is what? 1:5. So let me write this. Potassium manganate, we have done this. Then C1, yes, here. So how I'm going to solve? As I told you, make the ratio of, let me write it again. The value we obtained here was 4.77 times 10 to the power minus 4. And then remember, as I told you, the ratio is 1:5. If the manganate ions are 4.77 times 10 to the power minus 4, then how much moles of the iron 2 we have? So what is going to be? This is going to be multiply with the 5. So let me multiply with the 5 my answer, and the answer I obtained is 2.385 times 10 to the power minus 3. Is that clear? Now remember this value. This will help us a lot. Okay, that is 2.385 times to the power minus 3. Okay, now next part he says that calculate the amount in mole of hydroxylamine hydrochloride that has reacted in the Fa2 pipetted. So remember what we pipetted. Let me write and let me show you one more thing, because here we need that information that was given by the examiner. Here he says that 3.30 gram of hydroxylamine that were initially added to 1000 centimeter cube, which is equal to 1 dm cube. Okay, so 1 dm cube solution were prepared by adding this amount, and then we pipetted 25 out of that 1000 centimeter cube. Is that clear? So please remember this. This is going to be a help for us. So let me solve this part here. Okay, let me, now this is the final part, final selection for this question. Let me write the previous answer in the above part, that the previous answer was 2.385 times 10 to the power minus 3. This was the answer of the previous part. Remember that. Okay, I write it for you so that we can help. Now he says that, and furthermore, the solution was 1 dm cube. So solution was 1 dm cube, and here we added 3.30 grams. Then we pipetted out of the 1 dm cube that was actually 1000 cm cube. 1 dm cube is equal to 1000, and then we pipetted out of 1000 the 25 centimeter cube. Please remember this. Now to find out the moles of this, remember how much mole we have, gram we have 3.30. To calculate the moles, we know that this is equals to the mass divided by the molar mass. Okay, mR. So in this scenario, what is the mass? That is 3.30 divided by the molar mass of the hydroxylamine hydrochloride. This is the formula. So how many nitrogen we have? 1, which is 14, plus 2 plus 1, 3 plus 1, 4. We have 4 hydrogen. So molar mass of the hydrogen is, atomic mass of hydrogen is 1, so it's 4, plus we have 1 oxygen which is 16, plus we have 1 chlorine which is 35.5. When I solve this, let me say what I have. So 3.30 divided by the answer, that is 14 plus 4 plus 16 plus 35.5. So the final answer I'm obtaining is 0.047. Okay, let me 1 minute. 14 plus 4 plus 16 plus 35.5. So the answer is 69.5. okay, then 3.30 divided by 69.5. so the answer is, yeah, it's correct, 0.04748 0.04748. Your answer should be 3 to 4 significant figures. In this case, these are 4 significant figures. So remember, this is the mole, but that was in 1 dm cube. But we have to convert into 25. How? Remember, in 1000, the moles were 0.04748. But how much it will be if we use the 25 centimeter cube? So x cross multiply and then divide by 1000. So I'm multiplying my answer, the whole answer which is on my calculator screen. I multiply it with the 25 and dividing by 1000. Remember why I'm doing this. So the final answer, let me write first, 1.187. So I'm taking it 1.187 times 10 to the power minus 3. I'm repeating again. The answer here we obtained that was initially dissolved in 1 dm cube. But out of the 1 dm cube, we just used 25 centimeter cube. That is why I did this part. That's why I did this part. So the final answer in moles for the methyl, what was that, hydroxylamine is 1.187. Then finally he says that use your answer to C3 to deduce, mean the answer here, to deduce which of the 3 suggested equation corresponds to your results. Show your working. So this is actually the molar ratios. Okay, clearly write down the answer which you obtained earlier. That was, let me solve again, the volume which obtained NCV for the, what we can say, manganate ion, and with the help of the manganate ion we calculated iron. Okay, so that was actually, yes, I write it here, 2.385 times 10 raised to the power minus 3. This was the answer. So write it down, 2.385 times 10 to the power minus 3 ratio. This is for the iron 2 and this is for the methylamine. Okay, that is 1.187 times 10 to the power minus 3. Which one is the smallest? This one. So you have to divide this 1.187 times 10 to the power minus 3, and this is what, divide this as well. Why I am doing this? To get the simplified whole ratio. So this will be totally cancelled out, giving us 1, and when you divide this, so this will be cancelled, just divide this part. So 2.385 divided by 1.187. So the answer I obtained is 2.009. So that is approximately equals to 2. So the ratio I obtained here, 1:2. So now keep this value in your mind. Let me erase, and then I'm going back to check what of our equations corresponding to the ratio of the hydroxylamine. This should be 1, and the iron 2 ion, this should be 2. So 1:2. Where it is, let we go and check it, and then we write over here the correct equation number is, okay, what it should be. Go to the initial part of the question here. This is equation 1, 2 and 3, where the ratio is 1:2. So this is the equation 2, in which we have the hydroxylamine, that is 1, and the iron 3, which are 2. Okay, so keep this, and then here you can write your answer here. here you can write your answer as, what should be the answer? Here the answer we can say equation is 2, or you can write equation 2. I hope you get that. I hope you know how to perform your practical. I hope you learn how to calculate these equations. Your answer may vary because I just took rough titrations. I didn't perform any practical, but when you perform there might be a chance some variation, but as I told you, the procedure remains 100% the same. So my advice to follow the instructions, follow the procedure which we discussed. Okay, so with the hope we will see and we will solve a next question in our next video. If you have any question, any comment, you may not hesitate and write in the comment section. Take care till next video. Bye bye.